All right, so what we're looking at today is that we're looking at the collecting statistical data, and we're going to be looking at the first four sections, which is very vocab heavy. So what I've decided to do here is that we're going to go through a vocabulary throwdown, or it should be more wrestling, so it's a vocabulary throwdown! And that's what we're going to do, is that we're going to go through all the vocab that you're going to go over. There's about 27 words that we're going to go over, and let's start it up right now. So the first thing is population. The population is just a collection of individuals or a collection of objects in a group. So if you have a jar full of pennies, the population would be every single jar in that penny. Population of the entire world is every single person in the world. All right. So everybody, every object, every single person is considered a part of the population. Now, the end value. The end value is the actual number that is that. So if I have a jar full of pennies and there's 150 pennies, 150 would be considered the end value. The entire population, that number is called the end value. So whatever the total population is, the end value is the number of objects or people in the population. Now, data or datum. Now, datum is a singular for data. Data is the plural of datum. So data is what we're going to be using because we're usually talking about multiple things, so we're going to be using data. Now, data is basically Latin for something given. So whatever we're collecting is called the data. It's given to us. It's what we collected. All right. It's the information that we have are given to us. Now, a census. What a census is, you probably hear this every 10 years. You know, the U.S. is a census. They're trying to count every single person in the world, or in the U.S., which is basically impossible. You can never get a perfect number, so they're usually off by, I think last time they were off by like 1% or something, their estimate was. And basically what a census is going around collecting data from every single person or every single object from a population. So whatever the data they collect from every single person in a population, that is a census, if you get that. So in most cases, that's almost impossible to do. It takes way too much time, effort, and money to do that. So what we do is that we do something called survey. Not that survey, more of this type of survey. And what a survey is basically it's a gathering of data from a smaller group of people. All right. So you take it from some of the members of the population, not the whole thing, and that is called a survey. You take the smaller group. All right, and then you draw conclusions based on the information that you're giving. And so most times whenever you see information, you get it from a survey. All right, it's a smaller group of people that you get your information from. So now polling. Now basically polling is a type of surveying, and what it is that you're asking questions. So if somebody comes up to you and goes, "Hey, which do you like better, basketball or football?" and you go, I'm a football fan. You know, I'm a Panther fan or whatever people like for football." That is a poll. What they're doing is that they're asking questions and you're responding to them. So if they're asking questions in a survey, it's a poll. Now, a sample. Basically what a sample is a subgroup of a population. So if I have a group of people and I go, okay, all I want to do is I want to focus on a certain type, like only males, that would be my sample. My sample would be, you know, the males that I have taken for this information. Now, there's other things that we use for this. So sampling is basically the act of collecting this. So whenever of selecting our sample. So whenever we get our sample and we put our sample into a corner, that is called sampling. So it's the process of making your sample or selecting your sample. All right, now, the target population. Now, whenever you ask a question, there's going to be certain people that you're going to want to ask. Though energy drinks help people study. Well, when you do that, you're probably going to be asking more students, you know, high school or college. You're not going to be asking, you know, elderly people or, you know, people that are in their professions and in their careers where they don't have to study at all. All right, you're not going to do that. If you're asking, you know, which high heels feel better, you're not going to be asking construction workers that, because a construction worker usually won't be wearing high heels. Okay, so your target population is basically the population or the subgroup that you want to answer the question that you're asking. Okay. Now, a sampling frame is the actual subset. So you could say, you know, military. So anybody in the military, that would be your sampling frame. All right, it's basically the description of your sample of your subgroup. And that's what your sampling frame would be. All right. Now, selection bias, basically, whenever you do some sort of sampling or a survey, what's going to happen is that you're going to get some sort of bias in your survey. Okay, a lot of this it's impossible to prevent, and what happens with selection bias is that it's a built-in tendency. So, if you start asking people about, you know, if they drink energy drinks and you're only asking, you know, people that are up at like 12 o'clock at night, Well, more than likely they're probably drinking energy drinks, so you're going to be kind of swayed. And it could be just based on the certain group of the population. I mean, if you're only asking people in North Carolina what type of foods they like, it's going to be different than if you're saying, okay, well, the most common food in America that everybody eats is, rice and beans. Okay, it's just because it is for that certain area doesn't mean it is for the rest of the country. Okay, so you have some built-in tendencies, and that's called a selection bias. All right, now response rate. Now, sometimes what happens is that you'll put out a question to, in a letter or a call, and what happens is that people will have to respond to it. Now, the percentage of people that respond to it, that is called the response rate. Sometimes people will say, no, I don't want to do this, I don't want to do that, I'm not going to respond to this email, it's pointless, or I don't have time for this. Okay, so sometimes you won't have a high percentage. If you have a higher percentage, the better, because the more people that you're trying to target respond to the question, and the more well-rounded percentage you get for your sample. Now, non-response bias are the people that go, I don't want to answer that. So whenever you get a phone call and it says, hey, would you like to take time out to answer this question? And sometimes you go no, or you just hang up and hang up the phone. And if you have a non-response bias, it's basically you have a low response rate where a lot of people aren't responding to it. Now, the big key one that this happened to was back in the 1930s, I believe. It was for FDR's, I believe, his second election. And what happened is that the Literary Digest basically sent out this letter to a bunch of people that were, and it asked, who do you want, or who's going to win the presidency? And when they came back, they said, FDR was going to lose. It was like a 60-40 split, and he was going to lose. Well, if we know history, FDR ended up winning, and he actually won 60-40. And the reason they found this was because of the non-response bias. They sent out a ton of these surveys, but not many people responded back. And what happened was that they also had another bias. During this time was the Great Depression. And when the Great Depression was going on, a lot of people were moving to different parts of the country. People were going bankrupt, losing a lot of money. And what happened was that when they sent this stuff out, they only sent it to magazine subscribers and people with telephones. And at the time, not a lot of people had telephones. Number one, they were moving, and number two, it was a luxury at the time in the 1930s. So they only were really targeting the upper class, and which at that time in the history of the U.S., they wanted FDR out of the office at that time. Okay. So now, convenience sampling. Now, for convenience sampling, basically what it is that it's something that's done cheap and easy. That's all convenience sampling is. So if you ever go to a fast food restaurant and they go, oh, if you do this survey, you get a free hamburger, or you get free French fries, or you get a free drink, or you get 2 tacos, whatever, depending on whatever it is. And that is a convenience sampling. They're having you do it, and they don't have to put out too much time or effort to get it done. And this is done basically if it's not something that's super important, you just want to get kind of a well-rounded, over time information gathered, this is what you could use, okay? But again, you're not going to use a lot of money, you're not going to spend a lot of time doing it, and it's just easy. And quota sampling. Now, what quota sampling is that you take the information and you divide it up not the information, you take the population and you divide them up into groups. And what happens is you tell everybody, okay, I need you to get, 15 men and 14 women. I need you to get 3 left-handed people and 30 right-handed people. I need you to get this many tall people, this many short people. I need you to get this many blonde, this many brown-haired, and everything. So you set the population into groups, and then you force people to get a certain number from each quota to try to get a nice round and kind of blanketing information from all the people in the population. All right, now random sampling. Now what random sampling is that is sampling that's done with some sort of randomness. So if you go out and you look for certain people, that's not random because you're like, oh, I'm going to ask this person, I'm going to ask that person, I'm going to ask this person. And that's not random because you're picking the people. What random sampling is that there's chance in it. You have no idea who you're going to pick. It's just going to be some random people off the street that's going to answer this question. And that's what random sampling is. There's some sort of randomness in the sampling process. Now, basically a random sample is a sample that's taken when used with randomness, all right? So random sampling is the process of doing it, and a random sample is the information you get back from that random sampling. Okay. Now, a simple random sample is used, again, if you more like a convenience, it's cheap and easy. You put everybody in the population into a group, and you go, okay, we're just going to pick 100 people out of here, and those are the people we're going to ask. So it doesn't matter who it is. We're just going to mix everybody in a pot, stir it up, and just start pulling people out, and that's who we're going to ask. And I mean, it works sometimes, but usually what could happen is that you could get a very good selection bias. You know, you might have an overwhelming number of one type of people or one group of people that's disproportional from the rest of the population. So sometimes it's good for convenience, but sometimes it's not good because you're not going to get a nice round group of people for it. Okay. So again, it's just randomly taking people out, kind of like in a lottery setting. Now, stratified sampling. Now, this is a type of random sampling that's very close to quota. Now, remember quota, like a minute and a half ago that I was talking about. Quota sampling is basically you group everybody into different groups, and then you take a certain number from each one. And when you do this, usually you go through and it's people going out and they're picking the people as they're walking out. I want this many people. I want to get 10 Democrats. So then you look around, okay, I'm going to take these 10 Democrats that I see. Basically, with stratified sampling, it's randomness and you're putting people in the groups. So you go, okay, I'm going to put all the Democrats in one pile, all the Republicans in one pile, all the independents in another pile, and all the other third parties in other piles. And what happens is that from that group, you pick them at random. So you go, okay, I'm going to pick these 10 people from here, these 10 people from this group, these 10 people from this group, and it's completely random. There's no human choice in it. It's just random. All right. So stratified sampling is used for random, and it's picking people randomly out of certain groups. Now, these groups we're calling strata. Now, each of these groups are called strata, so you can have a strata of, left-handed people, you can have a strata of blue-eyed people, you can have a strata of green-eyed people, you can have a strata of people that like chocolate, people that are very religious, people that like Nickelback. I mean, you can separate everybody into certain groups, and these groups we're calling strata when we're dealing with a random sample. Now, when you're doing these sampling, what happens is that we get numerical data back. And when we get this numerical data back, we call this data statistics. So this subject that we're looking at, this overarching branch of mathematics that we're looking at, we call it statistics. But the definition that we're using the word statistics for is the numerical data that we gather back from these random samples, or any samples that we get, we're calling that number statistics. Okay, so any numerical data we get back is called a statistic. Now, the other half of that is the population information we get back. So if we were to take a census and get information from everybody in a population, that information, that numerical data, is called the parameter. And what that is the exact answer to the question. Now, the problem with this is that it's nearly impossible to get. It's too expensive. It's hard to get. Trying to do a census, trying to count everybody once and only once is basically impossible when you get a group big enough. And that's the actual measure of the population. Now, with the statistics and the parameter, we have something that we call the sampling error. Now, this is the difference between them. So if you do a sample and you see that 98% of the people like wearing collared shirts on Sundays. All right, that's a statistics. That's what we got from a sample. When you ask everybody in the population, that number could drop down to 95%. So we've got this 3% error that we have. So whenever you look at polling, you always see at the bottom they usually say, oh, there's a sampling error, or there's an error of plus or minus 3%. That's what they're trying to say. They're trying to say that there's some sort of error in this, but we don't know exactly what it is. And there's different calculations you can do to estimate what it is. And basically, the sampling error is the difference between what you've gathered and the actual number. Now, chance error. Now, whenever you do some sort of sampling, what's going to happen is that you have something called chance error, which is almost impossible to get rid of because chance is all over our life. Our life is chaotic, and there's no way of stopping it. Basically, what chance error is that there's going to be some sort of error in our sampling. There's going to be a minor bias somewhere. a miscalculation somewhere, you've forgotten a group of people. I mean, there's something that's small that could change the whole thing. All right. Now, with this also brings up a phenomenon called sampling variability. Sampling variability. And basically what it is, it's a phenomenon. What if you were to take a sample, if you sit outside of Lowe's Foods and you sit there and you go, okay, I'm going to ask the first 10 people to come up, and ask them a question. Do you drink 32 ounces of water a day? A minimum of 32 ounces of water a day. If you do that on a Saturday morning at 9 o'clock, you could get, the first 10 people you see, you could get 75%. Or 70%. 70% says, yes, I do. All right. You go back the next Saturday, do the exact same thing. Everything is exactly the same. Nothing has changed. You're even dressed the same. You might have, everything is exactly the same. And you asked 10 more people, you might only get 30%. So you have a change, even though nothing in your sampling has changed. And that is basically sampling variability. You have no idea of what's going to happen because of chance, because of chaos. We have no idea what's going to happen. And by taking a larger sample, we kind of lose, or this kind of becomes a less of a deal the bigger the sample we get. Now, sampling bias. Now, this is the bad thing about, this is bad when we have this. And what it is when you do a result and you give a sample, basically, and your sample is geared towards a certain group, so you've already kind of geared it towards a certain bias. Now, some people try to use statistics to try to prove their point, and they use this to their advantage. They might ask, do aliens exist? And what they do is that they ask people who they know do not believe in aliens. And they're going to gear their answers towards that because that's what they want to prove. And this is bad if you're trying to do this for a even out, this is an answer for the overall population. So that's what you have to try to do, and this can be eliminated, and it's very serious if it's in there. So we have to make sure we try to get rid of this. Now, sampling proportion. Now, this is the very last one. Basically, the sampling proportion is the ratio between the sample size and the total population. So you take the sample size divided by the total population. That is the sampling proportion, or what percent of the total population that we have sampled. All right. So that's all the vocab from the first couple ones. There's where it comes from, and all the images came from Google. So hope this helps. And the next one we'll go over capture, recapture, and clinical studies.